Okay, we're streaming live. We'll start in a few seconds. Today we'll look at section 2.5 on solving linear inequalities. Yeah, if you're online, go ahead and report in. Okay, first page. So one thing about linear inequalities is they're similar in a way to linear equations, but there's an important difference. So here's a definition. If A and B are real numbers, such that A is not equal to 0, then a linear inequality in the variable x can be written in the following forms. So the one on the left, we read this as A times x plus B is greater than 0. The second one, A times x plus B is greater than or equal to 0. The third one, A times x plus B is less than 0. And then the fourth one, A times x plus B is less than or equal to 0. We normally read equations and inequalities from left to right. So the greater than symbol looks like this. If we go from left to right, it implies that whatever is on the left is greater than whatever is on the right. Below that, we have the less than symbol. So whatever is on the left is less than whatever is on the right. And then greater than or equal. What we have on the left is either greater than or equal to whatever is on the right-hand side. And then the less than or equal to symbol, whatever is on the left is less than or equal to whatever is on the right-hand side. So in a symbol like this, the open side is on the side of the greater side, if that helps. We'll do some translating. Here, translate the following two statements from words to mathematical symbols. 5 is less than 11. So we just write 5 is less than 11. And then the next one, 18 is greater than 7. We translate that. We write 18 is greater than 7. Okay, we'll translate the following statements from words to mathematical symbols, and then also graph them on a number line. Okay, so this first one, a number x is less than or equal to 3. So in mathematical symbols, we write x is less than or equal to 3. Okay, on a number line, if we plot 0, and then we mark off a few points. On the number line, the positive numbers are to the right of 0. So we have 1, 2, 3, 4, and so on. To the left of 0 are the negative numbers. We can write negative integers, -1, -2, -3, and so on. Okay, you'll see graphs of these inequalities. You can see them in different ways. Since this is less than or equal to 3, we put in a solid dot or a closed dot, and then we shade the number line to the left, because on the number line, numbers that are less are farther to the left. So this is a closed circle. It's colored in. Alternatively, you might see a bracket instead of a closed circle. So I'll just squeeze that in here. If we have 0 and if we have 3, then if I put a bracket opening to the left and shade to the left, these two mean the same thing. So a bracket corresponds to the or equal to part. Okay, and the next one, a number y is greater than or equal to 9. So in mathematical symbols, y is greater than or equal to 9. And then on the number line, so I'll just put 0 here and I'll put 9 here. If y is greater than or equal to 9, then y could be at 9 or to the right of 9 on the number line. If you use a bracket instead, I'll squeeze that in. So 0, here's 9. Greater than or equal to 9, we have a bracket opening to the right, and then we shade to the right. Okay, the next one, a number w is less than 4. I'm going to move the camera a little bit. Okay, a number w is less than 4. So in symbols, we write w is less than 4. And so graphically, if we plot the number 4, well, since it's just less than 4, we put an open circle to indicate that 4 is not included, and then we shade the numbers to the left. So if it's a strictly less than symbol, then we have an open circle. An alternative way to graph, instead of an open circle, we can put a parenthesis that opens to the left, and then we shade to the left. So a parenthesis corresponds to a point that is not included. Distinguish that between the previous examples where a bracket is used when the point is included. Okay, the next one, a number m is less than 5 and greater than 1. Okay, a number m is less than 5 and greater than 1. Well, there's a couple of ways to write this in mathematical symbols. We can just write down what it says. We can convert portions of it. M is less than 5, so M is less than 5, and then write the word and m is greater than 1. But we can combine this in this case. So if m is greater than 1, you'll agree that 1 is less than m. So the way to combine this is to write 1 is less than m, which is less than 5. This is referred to as a compound inequality. We'll talk more about compound inequalities on Monday, but it's okay to break the ice now. So a formal way to read this compound inequality is 1 is less than m and m is less than 5. So if we graph this, then we plot the numbers 1 and 5. 1 is less than m and m is less than 5. So we put the open circles at the endpoints, and then we shade everything else in between. Alternatively, you could put parentheses at 1 and 5. Okay, the next one, a number n is greater than or equal to 6 and less than or equal to 10. So let's do the initial translation, similar to what we did in the previous one. N is greater than or equal to 6, and n is less than or equal to 10, and is less than or equal to 10. So we can write this in a more compact way. So if n is greater than or equal to 6, it also means that 6 is less than or equal to n. So we can write 6 is less than or equal to n, and n is less than or equal to 10. So this is the conventional way. It's not that writing the word and is incorrect, but this is more compact, and once you understand the notation, this is going to be more convenient. Okay, to graph this, then we just plot the numbers 6 and 10. Since the inequalities have the or equal to part, that means the endpoints are included, so we put solid dots or closed dots, and then we shade everything that's in between. So n is a number, any number that's between 6 and 10, which could include 6 or 10 or and 10. Okay, that's sort of an intro to the symbolic representations and the graphs of inequalities. Okay, the next page, we'll encounter an alternative notation. So on the previous page, we saw some examples involving algebraic notation as well as graphs, but you really need to learn the interval notation. The interval notation will be used in your later math classes, so you'll need to know that pretty well. Okay, so given an inequality in algebraic notation, graph it and then convert it to interval notation. Okay, so x greater than 3, we saw how to graph that previously. So plot the number 3, put an open circle, and then shade to the right. Alternatively, if you plot the number 3 and put a parenthesis that opens to the right, these represent the same set of numbers. Okay, for interval notation, the interval notation resembles the graph when we use either a parenthesis or a bracket. And the interval notation is also, the convention is to write the symbols as they would appear from left to right on a number line. So if x is greater than 3, we put a parenthesis that opens to the right, write down the number 3, and then a comma, and then positive infinity. So on a number line, if you go all the way to the right, keep going and keep going and keep going, you're heading towards positive infinity. So infinity is not a number, it's just a destination. It's just out there forever. Okay, so that's the interval notation. It means exactly the same thing as saying that a number x is greater than 3. Okay, the next one, x is less than or equal to 2. Okay, we'll graph it 2 ways. I'll plot the number 2. I'll color in the dot, and then x is less than or equal to 2. That's everything to the left. And then alternatively, if you plot the number 2, instead of a closed circle, we can use a bracket that opens to the left, and then we shade to the left. So those two graphs are equivalent. Okay, then the interval notation, this time, all or the numbers that are less than or equal to 2, those are in the negative infinity direction. So the interval notation, we put a parenthesis, negative infinity, comma, 2, with a bracket. The bracket next to the 2 indicates that 2 is included in the set. That's what the or equal to 2 part gives us. Okay, so x is less than or equal to 2. That's the algebraic notation. And it means exactly the same thing as this interval notation, the set of numbers from negative infinity to 2, including 2. Okay, the next one, x is greater than or equal to 4. So on the number line, we plot the number 4. Since it's or equal to 4, we color in the dot, fill in the dot, and then we shade to the right. Alternatively, we can use a bracket at 4, and then shade to the right. And then the interval notation, we put a bracket 4, comma, positive infinity. So the positive infinity doesn't need the positive symbol. The infinity symbol by itself automatically means that it's positive infinity. Okay, you getting the hang of this? It's really not too hard if you practice it for a few minutes. X is less than 5. So graphically, we put the number 5, open circle, shade to the left. The numbers to the left are less than 5. Or you could put a parenthesis and shade to the left. And then the interval notation, since the numbers go to the left forever, that means parenthesis, negative infinity, comma, 5 parenthesis. We always use a parenthesis next to a negative infinity symbol or a positive infinity symbol. We never use a bracket next to a infinity symbol, always a parenthesis. Okay, the next one, -4 is less than x, and at the same time, x is less than 1. So if we plot the numbers -4 and 1, if we use the open circles, then open circles at each of the 2 endpoints and shade what's in between. You could use parentheses, -4 to 1, a parenthesis at each of those, and shade everything in between. And then the interval notation, parenthesis, -4, comma, 1, parenthesis. Okay, the next one, 3 is less than or equal to x, and x is less than 6. So we plot the numbers 3 and 6. Since it's 3 less than or equal to 6, we put a solid dot at 3. But since x is less than 6, we put an open circle at 6 and shade in between. The alternative, we can put a bracket at 3 to indicate that 3 is included, put a parenthesis at 6 to indicate that 6 is not included, and then shade everything in between. And then the interval notation, we put a bracket 3, that means 3 is included in this set, and comma 6 parenthesis. A parenthesis is next to 6 because 6 is excluded. So I'll just mention something. A number that's less than 6 can be made as close to 6 as you want from the left-hand side. For example, 5.9999 is in that set. It's really, really close to 6, but it's not all the way to 6. So just keep that in mind. 5.999999. That's in that set because it's smaller than 6. Okay, the next one, 4 is less than x, which is less than or equal to 9. So to graph it, we plot the numbers 4 and 9. Open circle at 4, closed circle at 9, and then shade everything in between. We can put a parenthesis at 4 and a bracket at 9 and shade everything in between. One advantage of using parentheses and brackets when you're graphing is that in the interval notation, you're going to use the parentheses and the brackets in the same places, in effect. So the interval notation, we put parenthesis 4, comma 9 bracket. Okay, our last example on this page, 5 is less than or equal to x, which is less than or equal to 11. So we put 5 and 11, closed dots, because of the or equal to part in both places. And then we shade everything in between. The alternative, use brackets and shade everything in between. And then the interval notation, bracket 5, comma 11 bracket. Okay, so that's an intro to the interval notation. So in the software, you'll need to be able to submit answers using the interval notation. So whenever you're working in Newton and you don't know how to find something, there's a chat box on the lower right, and you can ask customer service. They can point you to the right place. Also, if you just experiment there's some little tables that you can access that have the symbols that you need, and you'll see a table that has different symbols on it, like 2 brackets or a parenthesis and a bracket, and so on. And you'll get used to it, but you'll want to make sure that you figure that out soon enough. Okay, we'll spend a few minutes just solving linear inequalities. Solving linear inequalities is similar to solving linear equations. So on this one, solve this inequality, write the solution in interval notation. So we have -2 times the quantity 11 minus 6x is greater than 74. So first, we'll go ahead and multiply -2 times the quantity 11 minus 6x on the left-hand side. So -2 times 11 is -22. And then we're going to subtract -2 times 6x. So we're going to subtract a negative. So it's okay for you to remember a -2 times a -6x is positive 12x. So we can just write plus 12x, and then this is greater than 74. So always watch out for the negative symbols in the subtractions. If you drop one negative symbol somewhere, then that will throw the answer completely off. Okay, in the next step, we can add 22 to both sides. So when we add 22 to both sides, we get 12 times x is greater than 96. And then when we divide both sides by 12, 12x divided by 12 is x, and 96 divided by 12 is 8. Okay, so the solution to this inequality is x greater than 8. So in interval notation, we put a parenthesis 8, comma, infinity. If it helps, it didn't say to graph it, but if it helps, you can say, well, x greater than 8, so I put 8, open circle, and shade to the right. And this can help you, perhaps. It can remind you of what the interval notation should look like. So that's all there is to that one. Okay, in the next example, so on the left-hand side, we'll apply the distributive property of multiplication over subtraction. So first, 3 times 4y is 12y. And then minus 3 times 1, so minus 3. This is less than 8y plus 13. From here, we can proceed in alternative ways. I'm going to add 3 to both sides. So I'll write, when I add 3 to both sides, we'll just have 12y on the left-hand side. And on the right-hand side, we'll have 8y plus 16 after I add 3 to both sides. In the next step, I'm going to subtract 8y from both sides. 12y minus 8y is 4y. And so I get 4y is less than 16. And then divide both sides by 4. 4y divided by 4 is y. That's less than 16 divided by 4, or y is less than 4. Okay, you can graph it if it helps. Plot the number 4, open circle, and to the left. So the numbers go to the left forever, so the interval notation is parenthesis, negative infinity, comma, 4, parenthesis. Okay, take a few seconds to work on this next one. I'll give you a minute or two, and then I'll do it, and then you can check your work with my work on it. Austin Cook here. Ariana Butler. Is that you? Damon Twendo. Hi, Dang. Zach Winters. Jose Varela, Jessica Becker, Marco Solter, Jacob Morgan, Richard Randys, Scott Haltoon here, Mrs. Fountain. Okay, let's try this. So make sure you multiply 6 times 3m minus 5 first. We cannot add 8 and 6 before we multiply. So we have to write 8 plus, and then 6 times the quantity 3m minus 5. 6 times 3m is 18m, and then minus 6 times 5 is minus 30. This is greater than or equal to, and then we multiply 2 times the quantity 8m minus 1. 2 times 8m is 16m, and then minus 2 times 1 is minus 2. We can simplify the left-hand side. 8 minus 30 is negative 22. So we'll write this as 18m minus 22 is greater than or equal to 16m minus 2. And I'm going to add 22 to both sides. So when I add 22 to both sides, I'll get 18m is greater than or equal to 16m, and then minus 2 plus 22 is plus 20. Then subtract 16m from both sides. 18m minus 16m is 2m, so I get 2m is greater than or equal to 20. And then lastly, divide both sides by 2. 2m divided by 2 is m, greater than or equal to 20 divided by 2 is 10. Okay, so if we sketch a graph of this, plot the number 10, close circle or a bracket, and then shade to the right. So all the way to the right, that reminds us that we have to go to positive infinity. So the interval notation, bracket 10, comma, infinity. That's the solution in interval notation. Okay, let's try the next one. So on the left-hand side, we apply the distributive property, 8 times n minus 5. And that's greater than or equal to 8 plus 3 times the quantity 5n minus 2. Okay, so on the left-hand side, 8 times n is 8n. And then we're subtracting 8 times 5, so we're subtracting 40. On the right-hand side, we have to multiply 3 times 5n minus 2 first. So we write 8 plus, and then 3 times 5n is 15n. And then we're subtracting 3 times 2, we're subtracting 6. Okay, we can simplify on the right-hand side first. So I'll leave the left-hand side the way it is for right now. So 8n minus 40 is greater than or equal to, and we can simplify the 8 minus 6. We can write that as 2 plus 15n. Okay, and I'm going to add 40 to both sides. So we get 8n. When I add 40 to both sides, I'll just have 8n on the left-hand side greater than or equal to 40 plus 2, which is 42, plus 15n. And I'll continue this up here. Now I'm going to subtract 15n from both sides. So 8n minus 15n is negative 7n. And this is greater than or equal to 42. I could have avoided the negative 7 coefficient of n if I wanted to. Earlier, I could have I could have subtracted 8n from both sides so that I get positive 7n on the right-hand side and negative 42 on the left-hand side. Hey, but in this example, we can use a very important thing that you need to remember. So at the moment, we have negative 7 times n is greater than or equal to 42. When we divide both sides by negative 7, we have to switch the inequality to less than or equal to. Okay, so we're going to divide both sides by negative 7. Negative 7n divided by negative 7 is n. 42 divided by negative 7 is negative 6. But since I divided both sides of the inequality by a negative number, I have to switch this to less than or equal. So we could have avoided that, but you need to know that that's what happens. If you divide both sides of an inequality by a negative, you have to switch the inequality to its opposite. The same is true if you multiply both sides of an inequality by a negative. You have to switch the inequality to its opposite. Okay, so n is less than or equal to negative 6. So on the number line, if you plot the numbers negative 6 and put a solid dot and shade to the left, this reminds us that negative infinity is involved because that's all the way to the left. So the interval notation then is parenthesis negative infinity comma negative 6 with a bracket next to the negative 6. Okay, let's get started on the next page. It's just more of the same on the next page. This one involves coefficients that are fractions. So let's find the least common denominator or the least common multiple of the denominators. There's just two different kinds of denominators. 5 and 2, so the least common multiple of 5 and 2 is 10. And so if we multiply every term on both sides by 10, we can clear the denominators. So multiply every term on both sides by 10 first. So 10 times 3/5, 5 goes into 5 once and into 10 twice. So 2 times 3b is 6b. And then 10 times 1/2 times b is minus 5b. And that's greater than or equal to 10 times 1/5 b is 2b. And then 10 times 1/2 is 5. We can simplify on the left-hand side. 6b minus 5b is just 1b, or b. And that's greater than or equal to 2b minus 5. So I'm going to add 5 to both sides to get b plus 5 is greater than or equal to 2b. And then subtract b from both sides, so we get 5 is greater than or equal to b. So 5 is greater than or equal to b. Note that 5 greater than or equal to b, that's equivalent to b is less than or equal to 5. So are we in agreement that those two inequalities mean the same thing? So sometimes it's easier to put it in a form that you're used to, like reading from left to right, b is less than or equal to 5. So we can remember how to graph that. We plot 5, color in the dot at 5 and shade to the left. So if b is less than or equal to 5, the interval notation, negative infinity, comma, 5 with a bracket. Okay, let's go ahead and get started on the next one. This is just more of the same. Just watch all of the details. So here we have 8y minus 3 times the quantity y minus 2 is greater than 2y plus 4 times the quantity 2y plus 4. So the first thing we'll do is apply the distributive property of multiplication over subtraction on the left-hand side and over addition on the right-hand side. So we get 8y, and then minus 3 times y is minus 3y. And then minus 3 times negative 2, which amounts to adding 6. You can remember that negative 3 times negative 2 is positive 6. And then on the right-hand side, greater than 2y plus 4 times 2y is 8y. And then plus 4 times 4 is plus 16. We can simplify further on both sides. 8y minus 3y plus 6 is 5y plus 6 on the left-hand side. On the right-hand side, 2y plus 8y plus 16. 2y plus 8y is 10y. And I'm going to subtract 5y from both sides. So on the left-hand side, we'll get 6. And this is greater than 5y plus 16. Then we'll subtract 16 from both sides. 6 minus 16 is negative 10. Negative 10 is greater than 5y, and then divide both sides by positive 5. Negative 10 divided by 5 is negative 2. Greater than 5y divided by 5 is y. So negative 2 greater than y, this is equivalent to y is less than negative 2. Okay, so the interval notation, if y is less than negative 2, we put parenthesis, negative infinity, comma, negative 2, parenthesis. Okay, I guess we'll stop there for today. And on Monday, we'll start the next section. If you're behind in Newton, make sure that you get caught up soon. Also, there's a quiz for you, a video and a quiz in Moodle. So go to Moodle. I'll send you an email to remind you about the Moodle quizzes. But that's all for today.